All right. Here we are back again. Day 3 of heat exchange, conduction, convection, and radiation. Today we are going to add a couple of more topics to our vocabulary list as well. Let's go ahead and start digging into this. Yesterday, as we went outside and sat down on the ground and let our rear ends get cold, we realized that when two things are touching, such as ourselves and the ground, heat passes from the warmer thing, us, into the ground. And when two things are touching, we have conduction. We have conduction. So anytime heat passes when two things are touching, we know that that is conduction. Slide contains audio. I don't know what that is. We'll just do this device only. I must have narrated it myself. Cooking an egg on a stove. Because the egg is touching the stove, you have conduction. Just like yesterday, same examples. Ice melting in your hand is conduction. The heat is moving from your hand to the ice. And when you have two things touching and there's a transfer of heat, we know it is conduction. We talked yesterday a lot about an animal lying on a cool patch of dirt and how that's actually kind of an interesting thing that happens. But we have conduction. Along with conduction, we have other methods of heat transfer, such as convection. And convection is when heat transfers through a gas or through a liquid. For example, and you can look in here and you can see this convection cell going on inside of this pot of water. Boiling an egg is convection because it's moving it through water. The movement of thermal energy around the earth, when we have the sun heating up the earth, which causes warm air to rise and then cold air sinks in to replace that. Again, it looks very similar to this convection cell. We have convection. Boiling water is convection. We talked about convection ovens yesterday as well in class. Were ways that we're moving heat around in an oven to cook in a convection oven. So convection is a little different. There's not a lot of touching going on. It's not like one object touching another. It's heat being transferred through a gas or through a liquid. We have another way, and that is radiation. And it was very interesting as we had sat outside in the cold yesterday. We realized that when we moved into the sunlight, all of a sudden it really wasn't that bad outside. Most of us thought it even felt kind of good. And we realized that the sun is transferring heat through heat waves or electromagnetic rays. And we called that radiation. So we have conduction, we have convection, and we have radiation. And there are two big ways that you're always going to see radiation, and as far as examples, two main examples. The sun heating the earth and getting warm beside the campfire. Notice this person is beside the campfire, not over top of it. That's a different story. Knowing that we have heat transfer. We have heat transferred through touch. We have heat transferred through gas and water. And we have heat transfer through radiation. There are going to be times that we want to have that happen very quickly. And there are going to be times we want that to be stopped. We don't want heat to transfer. Like yesterday when we were sitting on the ground, that was a time where it's almost like you wish you had something to sit on to stop the heat going. So if you had like a sleeping bag or something, it could stop some of the heat moving from you to the ground. And so we have two things called conductors and insulators. Conductors and insulators. Conductors are materials that heat goes through them very quickly and very easily. If a material allows heat to move through it very fast, you would consider it a conductor of heat. One of the reasons why when you go to Starbucks and get a hot coffee that they don't put it in a metal mug, not your double-walled like things that you have, like your hydro flask and stuff. Those are different. Those are made different. I'm not just like a flat metal cup. If you pour hot coffee in a metal cup, it's going to burn your hand. because metal conducts heat very quickly. And we'll talk about why hydro flasks work the way that they do. There's a video in here, I think, later on in these slides. But conductors are things that let heat move through them. When is that an important time? When do you want heat to move through something very quickly? Well, there's some examples of that. Iron, gold, copper, silver, aluminum. Notice this toaster in the background. I want heat to move through that very quickly. I don't want to put my bread in there and have to wait 6 weeks for it to make toast. I want it to do that quickly. That's why the wires inside that have electricity, things that are able to go through them, are able to conduct heat very quickly, and it gets things hot very fast. That's why if you're looking inside of a stove, the rods, or the top of the stove too, the rods that are heated up on the stove, those coils that you see on many stoves, are made out of metals, because metals conduct heat very quickly, and there are times that you do want heat to be conducted very, very quickly. And that was when you would need something called a conductor. Other times you want something that does not let heat move through it very quickly. And that would be something called an insulator. Your jackets are not made out of metal, because if you had a metal jacket on, it would not take you very long at all to go outside and get cold. Your jacket is made out of different materials, cotton and things of that nature, that insulate you. They don't let heat move through you very quickly. They keep the heat out, which is something that your house has insulation, keeping the heat out in the summertime. And that same insulation keeps the heat inside of the house during the wintertime, because it doesn't let the heat, when you turn on the heat or build a fire, escape. When you wear your jacket, it keeps the heat in. It keeps the heat next to you. It doesn't let the heat from your body move outside of the jacket very easily, because it is called an insulator. An insulator. Insulators are not good conductors. They are bad conductors of heat. Plastics are typically bad conductors of heat. If I take a metal spoon and I move it around in a hot pot of water, and then I touch that metal spoon, I'm probably going to burn my hand. A plastic spoon, I can take it, stir it around in the water, and basically leave the spoon in the water. And I can grab the handle 5 minutes later, and the handle is still the same temperature pretty much. A metal spoon, if I left it in boiling water, it would get hot over time, because plastics are good insulators. They are bad conductors. Your oven mitts that you use, they don't let heat move through them very quickly. That's a good thing, because when I pick up something out of the oven, I don't want heat to move into my hand. Thermal underwear, something some of us might be wearing tomorrow. Matter of fact, thermal underwear keeps the heat from your body escaping. Wood is another really good insulator. A lot of handles of pots that I've seen are made out of plastic, and a lot of them are made out of wood, because wood does not conduct heat very good. It kind of keeps heat from transferring through it. So insulators are something that's very important. Now, there are some videos. I've got to check on this one. This one's not showing up for some reason. I got to find out what's going on. But here, and we will get into this later on, but this is why your hydro flask works the way it does. Mr. Bullens, you told me metal is a good conductor of heat. How come when I pour hot coffee in my Yeti, or what other hydro flask company you happen to be using, why does it stay hot or cold all day? Well, it happens to do with this space in here, which is actually filled with air, and it is extremely hard to move that heat through that portion of the air there and then to the outside. So it is an insulated container. I can't show that in this video, but you'll have Nearpod code where you can watch that if you want to. You'll be able to, holy cow, 12 question quiz. Want to check on that. I don't know if I'm going to get through all that today or not, but we'll see how we do. When we were outside yesterday, we talked about different colors and the way that they absorb heat and the way that some of them reflect heat, and how that these colors are used in the designs of different clothing. Many of our winter clothes are darker, and they have more cotton and things inside of them because they are there to keep you insulated. They keep you insulated, and they also absorb heat. So if you are outside all day on a very cold day and you're working, you might want a black coat to absorb all that heat. With that being said, you may not want your clothes to absorb all of that heat. You may want them to reflect some of the heat, and because you don't want to take in all the heat. If you're going skiing, if you notice a lot of ski clothes, they have a lot of insulated materials inside of them, but not many of them are made with super dark colors. A lot of them are made with very bright, vibrant pinks and yellows and whites. And the reason for that is you're already up on the mountain moving around a lot as it is. And you don't want your clothes to be absorbing the sunlight all day because it might make you too hot. So there's a lot of science that goes into the design of these clothes. Now, a lot of it, honestly, is just, it looks cool. There are a lot of people that say, I want a black jacket, period, the end. Don't care. There's a lot of people that say, no, I want my jacket to have pinks and yellows and oranges and greens in it because I like the color scheme. And that's okay, too. I'm not saying every shirt and hat, that they're thinking, oh, I wonder if this is going to absorb or collect heat. That's not what's going on. But some of it most definitely talks about how different colors absorb and how some things reflect heat. One amazing thing that I think that's pretty awesome is scientists have done some research in this. And we all know that plants need sunlight to make energy. They need it for photosynthesis. So you might be thinking, well, why aren't all the plants black? If they were black, they could absorb more sunlight. And if they did that, they would get too hot and they would all die very quickly. It just so happens to be that green is the perfect color for plants. It absorbs just enough sunlight and reflects just enough light that it is able to be in perfect harmony with the sun and make its own energy. And it also has that transpiration with the sun shining a little bit brighter. So plants are pretty cool in the fact that they have that adaptation of being the perfect color. I think that's something that's very unique, something to think about, and the way that we have different colors and how green just happens to be the perfect color. I'll see if I can find that scientific study that I was reading on. It's a little complicated. I didn't understand everything that they were saying in there, but the overall gist, I think you could probably even get it and enjoy it. So I'll have to try to post that if I can in our Google Classroom. Again, like we said, dark colors absorb the light and the heat energy better than lighter colors. Again, if you're outside on a sunny day in a white shirt and your friend's in a dark blue shirt, they're going to get hot faster because their shirt absorbs more heat. I remember I was playing tennis with my friend one time, and we had both bought some of those moisture wicking shirts. And I don't typically wear a lot of black t-shirts. I usually wear like grays and blues. And I had found a light gray shirt. He happened to really enjoy black shirts, so he bought a black shirt. And we played tennis for about 30 minutes. And after about 30 minutes, he says, I think I've made a huge mistake. I'm dying inside of this shirt. Like, I'm sweating more than I ever have. And even though this thing's supposed to pull sweat away from me, the dark color is just too much. I've got to go get a different color. So that's pretty cool. I want you to think about that, the dark colors and the light colors. I want you to think about insulators and conductors. And I want you to think about conduction, convection, and radiation, because we've got a very fun, small project we're going to work on here pretty soon, where we're going to design some clothes and some houses based on what we know about these things. That is it for today. I hope you enjoyed. Smash the like button and subscribe. See you later.